All right, welcome back. It's time for us to start working with databases in our applications. And before we actually write code, I just want to take a few minutes here, this will be pretty quick, to talk about what databases actually are, and then to introduce two broad categories of databases, which are SQL databases, or SQL, versus NoSQL, or NoSQL databases. Okay, so let's begin here. And to start, I want to illustrate the problem that we have right now. I have the post request demo running, this Friends app, where I can list all my friends, and we can add some new friends. I just made a new one today named Garfield, and another friend named Hermione. Okay, and then I can go back here, and if I shut off the server and start it again, and I refresh my page, gosh, I just lost two friends. So the problem that we're facing is that our data doesn't persist. If our server stops for any reason, whether it's because we turned it off, we wanted to restart it, we made some changes to the code, or if it's because the power goes out or some freak event happens, if the server stops, we would lose all data, which is obviously a really, really bad thing for a real web application. If Facebook lost your data every time you logged out or every time the server stopped, that would be really, really bad for Facebook, although it might be pretty good for me. I'd be productive, I'd stop comparing myself to my friends, I'd stop trying to prove to everyone that I live a fun life, and I'd just get stuff done. So all of this is to say that databases will help us with this problem. So let's talk about what databases are. In the simplest possible definition, a database is a collection of information / data. But a database isn't just a collection of information. So if we had a file, just a text file in Sublime, that had a bunch of information and saved it, that wouldn't be a database. Yes, it might store data for us, it might be a collection of information, but the other important aspect of databases is that they have an interface for interacting with that data, whether it's adding new information, like adding a new user to the database, or if it's removing all users, or editing an existing user, whatever it is, there needs to be a way for us to interact with the data. So a database is a collection of information / data, and it has an interface. When I say interface, I mean that we can write code to interact with it. So if you've ever worked with a SQL database before, you might have seen things like this. Select star, I should capitalize this technically, select star from users, or you might see something like insert, blah, 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 into, and this is a language called SQL. And this is the interface to some databases. The language that we'll be using looks like this. db.dogs.find or db.dogs.delete, and we'll delete the dogs where we have age is 14. Unfortunately, all my dogs have died at that age. I don't want to talk about it. And we'll delete all dogs where age is 14. We'll get into the specifics of this language in the next video, but I just want you to be aware this is what I mean when I say that there's an interface to the collection of data / information. Okay, so the last thing I want to do is talk about the two broad categories, or two of the broad categories of databases. And those are SQL, which is also called relational databases, versus NoSQL, NoSQL, which are called non-relational databases. When I'm talking to my students about databases, a lot of them have had some experience with some sort of database, whether they were in marketing or retail or something online. Pretty much every company out there has some database, usually lots of databases with lots of information in it, whether it's a database for all of the SKUs in the Gap, or a database for payroll of all the employees and what they've been paid and when, or if it's a bunch of data on users like Facebook has, where it's storing all of your user information, all your photos, your comments, your posts, your likes, your tags, all of that stuff is stored in databases. When I talk to students about databases, the students who are familiar and have experience with databases almost always only have experience with SQL or relational databases. And that's because SQL databases have been around the longest, and they're what most people think of when they think of a database. So now let's talk about what a SQL database is, what relational means. So SQL databases are tabular databases, and they're flat. Let me show you what I mean. So I have some crude diagrams that I typed up, and this is showing what the tables for a database involving users and comments could look like. Let's just start by focusing on the users. So what we have to do in a relational database or a SQL database is we define what a user looks like. So one user has an ID, has a name, an age, and a city. And then every single user that we add must follow that pattern. So we're defining these tables, and then we're adding instances of the user or of users to this table. And then let's suppose I also have comments. So I want a user to be able to comment. So I have a comments table, and all that a comment has is an ID and some text of the comment, like LOL or come visit Montana or I love puppies. If I want there to be a relationship between users and comments, where a user can have a comment that is associated with it. So Ira here, who's 24 from Missoula, can be associated with some of these comments here, like come visit Montana and seriously Montana is great. The only way to do that, to express this relationship, is through another table, which is what we have here. And these are called join tables. And what this table does is it joins a user's ID with a comment ID. So in this case, we see that the user with ID 1 owns the comment with ID 3. So that means that Tim said that I love puppies. And the user with the ID of 2 commented twice, and those comments are ID of 2 and ID of 4. So we can see that Ira commented, come visit Montana, and also, seriously, Montana is great, and yes, Montana is great. What I really want to show with all of this is that everything is tabular, so we have to define a table ahead of time, and it's not very flexible at all. Let's suppose I wanted to add another attribute to Ira that was favorite color, and I want to set it to be purple. I would then have to go and add favorite color for everyone. Let's just call it fav color. And it would have to be empty, so I'd have to have null or undefined or nil or just false or something here for every single person. So it's not flexible. What I have to do is define exact patterns of what a user looks like, and then I need to follow that pattern very closely. So the other type of database is non-relational databases or no SQL databases. And you probably catch where I'm going here. We don't have to define patterns ahead of time. They're much more flexible. So here's an example of representing Ira using a non-relational database. There are no tables, so we don't have to define this tabular structure, and things can be nested, so it's not a flat database. So you can see here, it looks just like JavaScript. In fact, it's really, really similar. It's something called BSON, which stands for Binary JavaScript Object Notation, but it's basically JavaScript objects that we're familiar with. And I have a bunch of key value pairs. So name is Ira, age is 24, city is Missoula, and then this is the really important part. Comments can just be nested right inside of the data. I don't have to deal with IDs. I don't have to define this table ahead of time. I can just nest comments in here and just start adding objects. And if Ira comments something else, I can just add in another comment, push into that array. And so this comment could say, why does no one care about Montana? And that's a really good question. I don't know, Ira. So we end up now with this very, very flexible structure where if we wanted to, I could just define favorite color down here. Fav color is purple. And then I could have a whole other user who is named Tammy. And Tammy can be 24 from Missoula as well. And she won't have a fav color at all. And instead she has favorite food, which is ribeye. All right, so that's enough of that. What I really wanted to focus on with all of this is the difference between relational and non-relational. So not the nitty-gritty details of the syntax or how it actually works, just the broad difference that SQL databases or relational databases have been around the longest. They're what most people think of when they think of databases, where we have to define a table, everything is tabular, and if we want to relate data, we have to have multiple tables to relate that data, and we often use IDs to do that. With a non-relational database, which is what we're going to be focusing on for most of this course, we don't have to define any sort of tables. We don't have tables at all, actually, and instead, we have a much more flexible structure. Now, this isn't to say that non-relational databases are better. In fact, in a lot of cases, they're not, almost in all cases, but there are specific situations where they make sense, and I'll talk about why we're using a non-relational database in the next video. But I don't want you to get the impression that because this is more flexible, it's inherently better. That's not the case. But it is more flexible, which if that's what you're looking for, then you want to use a non-relational database. All right, so let's wrap this up. A database is a collection of information. It has an interface, some sort of language, some sort of technology or tools to interact with the data, add new things, read things out of the database, delete things, edit things. And then there are two broad categories of databases, SQL and NoSQL. Okay,